Hi, boys and girls. It's Miss Manning here. We're learning Module 5, Lesson 13, where we're learning to find the area of a rectangle with mixed numbers as lengths and widths. So it's mixed number times mixed number, and we're trying to move away from the area model, but we still need to remember that area is length times width. And the way that we're going to be able to take a mixed number times a mixed number is if we learn how to convert those mixed numbers into improper fractions. We have to remember our skills for multiplying fractions, which is numerator times the numerator and denominator times the denominator. And then when we finish, we have to look at that fraction that we have as a division problem, remembering that our denominator is always the divisor. So for my lesson today, we are going to need to know how to take a mixed number and convert it into an improper fraction. So for us to do that, I got out 1 whole slice of bread and then 1/3 of bread. So the 1 represents my whole number. This part right here represents my 1/3. So for us to convert this to improper, it has to be the same denominator and it has to be split into thirds. So I'm going to take my whole slice of bread and I'm going to split it into thirds. And now I need to count the number of thirds that I have. Well, I have 1, 2, 3, 4. I have 4 thirds. So I haven't changed the value. I didn't pull out more bread to convert it from a mixed number to an improper. But all I did was talk about it in terms of thirds. But the question is, how do I do that mathematically? Well, what we did was we took this whole number. That's the number of copies that we made. But we made copies of a whole number in terms of thirds, which would be 3 thirds. And then we had to add to it our fraction from the previous problem. So 1 times 3 thirds is 3 thirds plus 1/3 equals 4 thirds. So now let's do that with one that might be a little bit harder. Let's do 3 2 thirds. So mathematically, we want 3 copies. 3 copies of thirds, but it has to represent a whole number. What represents a whole number? 3 thirds. That's equivalent to 1. But we want 3 copies of those because there's a whole number here. And after we do that, then we need to add our fraction from up here, which is 2 thirds. So 3 thirds times 3, that would be 9 thirds plus 2 thirds equals 11 thirds. With problem set number 3, they want us to find the area of Mr. Howard's yard and then subtract our pool area and our sidewalk and the pool house area because he's going to be laying down sod, which is kind of like carpet, but it's like grass that's been grown and you can lay it down and it grows. So he obviously is not going to want to lay sod on his pool house or on the sidewalk or the pool area, so we get to subtract that. So let's find the area of his total yard and then we can subtract those. So 24.5 yards long, and it's 24.5 yards wide. So that's what we're going to be multiplying. We could multiply this with the area model, but we're trying to move towards improper fractions. So remember that's going to be, we need 24 copies of what's a whole with a denominator of 2. Well, that's 2 halves. And then we would add our other fraction there. So 24 times 2 halves is 48 halves plus 1 half, which equals 49 halves. And because this is a square, we don't have to do the other dimension because we've already done the work for it. So this is 49 halves of a yard by 49 halves of a yard. So now we can multiply our numerators and our denominators. Well, I can do the denominator pretty easy. 49 times 49, I'm going to have to do up here. 9 times 9 is 81. 4 times 9 is 36 plus 8 is 44. Now I'm done with my ones place. I'm going on to the tens, which means I need a placeholder 0. 9 times 4 is 36. 4 times 4 is 16 plus 3 is 19. 1, now I add those two, 1 plus 0, 4 plus 6. I'm going to add my 9 and my 1 to get 10, plus 4 is 14. So I end up with 2,401 fourths. And then we're supposed to take that fraction and turn it into a division problem. And my kids are probably tired of hearing this, but I say in my classroom all the time, our denominator is always our divisor, which is what we are dividing by. We're dividing by 4, we're dividing by it into fourths. So I can't do that one just with, it's not a basic fact, so I'm going to do some long division. Divided by 4, does it go into 2? 2 divided by 4 doesn't work. So I bring down my 4. Now I have 24 divided by 4, which is 6. Then I multiply 4 times 6, I get 24. Bring down my 0. I have 0 divided by 4. Goes in there 0 times. Looks like a funny little face I've just drawn. And now I have my 1 to bring down. 1 divided by 4, I can't do that. So I'm left with a remainder of 4, which I'll use in my fraction up here. And if my denominator is always my divisor, then my divisor can become my denominator. So this is going to equal 601 yards, but that's not all of the problem. All we've done is find the area of Mr. Howard's yards. For you to complete this problem, what you're going to need to do is you're going to need to take the area of the pool house you're going to have to subtract the area of the pool house from there, but you're also going to have to subtract the area of the sidewalk. And I suggest doing this bit by bit. And then you're also going to have to subtract the area of the pool because he's not going to lay sod down on those areas. So after you've taken our total area, you've subtracted the area of the pool house, which they've given for you, the area of the sidewalk, which shouldn't be too hard to find, and then finding the area of the pool and subtracting it. What you are left with is going to be the area of the sod. You're going to have that grayed in area, you're going to find that area for you. Thanks so much, guys. That's all I have for you today. Be sure to bring any questions that you have over the lesson to your teacher in your Zoom meeting.